Longtime member, obviously been very good to the meetup over the years. And previously, before he became cool, he used to be a music photographer. And he actually toured with a bunch of bands. And if you want to see his work, he's in Chris Payne's Oral History of Emo. Yes. Please welcome Rick.
Kick us off. So first of all, hi, everybody. I'm Rick, or Ricky. My pronouns are he and him. I'm going to actually kick this off, my talk, by sharing a story of a really great flop of ours. So I used to, I've run a few data teams throughout my life. Maybe about 10 years ago, probably around the same time Jad was talking about of when we made these shirts for the R meetup. I was at a music company, and we had an awesome data science team. There was this astrophysicist on my team who taught me these really awesome stuff about time series and random forests and all sorts of stuff I didn't know before then. And because we're in the music industry and the music is a hits business, we set out to predict hits. We had a wealth of data. We had a bunch of data from, I don't even need to mention the companies, but you can imagine all the really awesome companies out there where you can get some streaming data, you can scrape some data off the internet. We build these amazing models. We even went through the process of starting to patent some of these. And it took us, I don't know how many months to develop it, maybe 2, 3, 4 months. When we're ready, right, we were tuning them, going through, we were thinking we got some pretty good results, and we're ready to showcase it. It's a small startup. There's about 15 of us. So we're all gathered around a monitor that looks kind of similar to the one here in front of me, right? But it's up on the wall. And we're showing the results of these models, right? We're showing them live, and it's like we're doing a little bit of like back testing, right? Here's what the model's going to output of these artists that are going to blow up, and we start to actually pull up these artists, and we're like, whoa! It was something like 80% of the top 20 artists that our model predicted had all blown up and had flown under the radar. That's amazing. Right? We're like, whoa, like all 15 of us celebrating like crazy. And someone's like really excited, and in all sincerity asks, what are we going to do with this? And we're like, what do you mean, what are we going to do with this? We thought you'd know. And I kid you not when I say we built this amazing model, and for ages, it's just sat there on a shelf, right? Because we didn't actually figure out what happens after we make this really awesome model. Right? So today I'm going to talk a little bit about all the parts of data that have nothing to do with data. All the data work that's necessary before and after, but really just focusing on like the one most important question that essentially every team needs to answer, which is this. It's what work should my team do in order to ensure success? Now, I use the word team here because it's an easy phrase to use. For a lot of my career, I was a team of one. A lot of folks I talk to I know are also teams of one. Everything I'm going to say tonight or today applies whether you are a team of one or a team of 20, whether you have multiple teams all working together, and it's really a team of teams. I'm just using this term pretty loosely here. So just a little bit about myself. So Rick went through that. I'm currently working as SVP of Data at a company called Entera. I've been in this industry for about 2 decades now. I used to head up the Data Strategy and Insights department at the Farmer's Dog. If you watch any of the Super Bowl commercials, they had that amazing dog commercial that just got nominated for an Emmy this week, which is just amazing. And then prior to that, I was VP of Data at a company called Vydia that was recently acquired by Gamma, and The Orchard, which was acquired by Sony. Most folks here have never heard of The Orchard, but if you listen to anything on Spotify or iTunes, there's about a 70% chance that our pipes actually put that music there. And then prior to that, I worked at many other companies, some BI companies. I did data product management at a large insurance firm and a whole lot of other stuff. But let's clarify some terms really quickly. Things on the left are not the same as the things on the right. This term, data product management, has come into fashion, and I really like to distinguish it from the concept of managing data as a product. Very similar terms. They are not at all the same thing. Managing data as a product is about giving data the respect it deserves and actually managing it correctly. Data product management is about what we do with data, what it enables us to accomplish that we can't otherwise accomplish. But let's also define success here. So success of any team, but by the way, just really quickly, I got a little bit nerdier on this talk, given the nature of the audience here. trying to get a little bit mathy. But I think we can define success of a team with these two basic concepts, right? Which is the value of our work and the value of our work relative to whatever we call the investment in it, right? So we're investing our own time. We're investing our own time. We're investing efforts. We're renting machines somewhere to run stuff, or we're buying really expensive machines. And so we really want to figure out, does this work generate some sort of value above some threshold? Right? In industry, you generally measure this as some sort of dollars in, dollars out. In academia, you might measure it as something around papers published. But ultimately, you're investing your own energy, your own time, all the things you could be doing with your life instead of doing this, and you're asking, is it worth it? Right? So I'm going to jump around here a little bit, and I appreciate you all bearing with me as we do this. But we want to ask the question of, how do we measure success? How do we know if we are succeeding? And so very simply, if the total value we're producing is above our threshold, and if the total value relative to the investment is above the other threshold, we're going to call that success. But really what we care about is, how do we ensure success, right? This is how we define it. How do we ensure it? We're going to tap into that mathematical part of our brain, and we're going to flip it and say, well, let's assume failure and what went wrong, and we're going to analyze it from there, right? So assume that we're failing. Assume that our team is not succeeding. What's happening? One of those two thresholds are not being met. Right? And actually, even before that, excuse me, we could say either we're doing great work or we're not doing great work. If we're not doing great work, I'm just going to say that all of that is outside the scope of this talk. Right? If we're not doing great work, there's probably some disconnect between the capabilities of work. We'll keep that outside of this. But really what we care about is, assuming that we are doing great work, but yet our team is still not succeeding, why are we not succeeding? Right? Think about so going back to that story at the very beginning. We did amazing work. We built amazing models, right? 80% of the top 20 results of that model actually were successes. And yet, it was completely useless, right? I would not say that we did great work. I would say we created great math models that accomplished nothing, right? And it's a very humbling idea. And so if we are doing great work, and yet then we're failing, right? We're assuming failure here. We're trying to understand why we're failing. One of these two things are true. We're either the total value of our work's not hitting our threshold, or the value to effort ratio is not there, right? Essentially, like, there's no ROI. Either there's not enough value in our work, or there's not enough return on investment of our work. And we can actually start breaking these through. So if our work just as overall is not producing enough value, right? It's either not getting used, or the work's getting used, but it's not producing enough value by itself, right? This latter one's a little bit easier. If it's not producing enough value, what it means is essentially what we thought was valuable, we were just wrong. We had some estimate before we got started with the work. We decided we would do this. Turns out we were completely wrong. Or we're actually right about it. It just hasn't been integrated correctly. And we're going to talk a little more about handoffs and integrating it and how challenging that is. More often than not, what happens is data science work, or data work as a whole, ends up not getting used. I'm sure, show of hands, how many people here have actually built something that ended up on a shelf in an email box, no one ever used it, right? If you all look around, it's like literally everyone's raising their hands right now, right? That happens for a variety of different reasons. People don't know how to use our work, or the work arrived way too late. We don't know how to integrate it. They have other things going on, right? It just wasn't really a priority. Or they never needed it in the first place, right? All these different reasons why we build something and no one uses it. This is all assuming that the work itself is not producing value. Alternatively, maybe the work itself is fine, but the ratio relative to how much effort we put in is off, right? And therefore, when we look at our team as a whole, we feel like our team is not succeeding, meaning we're putting in all this time, all this effort, we're getting good stuff done, but just not enough of it. That's normally how I think about it, right? If you look at data science teams, a lot of really great data science teams produce an amazing result one time. And there's this one major project that they've gotten done, and that's about it. And this one major project pretty much takes up the whole year. Or sometimes you'll have one really great project, and maybe like 2 or 3 little trinkles of something throughout the year, and that's about it. And then year over year, and when you look at the plans that they make for the year, okay, well, what are we going to do next year? We're going to do these 4 really big things. and then the year comes to an end, and they did maybe one of them. So generally, that looks like the work we're doing is taking longer than we thought. And this one, there's a variety of reasons why this happens. We don't know when to stop the work, right? And this is like, we're aiming for model performance that's way too high. We don't have a clear definition of what's in and out of scope. We're taking on the wrong massive projects. We're doing these really giant projects, and it's not even the right one to do. There's something else that we could have done. There's other value there. I'm not going to go through and read this entire list, but you can imagine there's a whole lot of reasons of why our work fails. And we start getting a sense of, if we're failing, there's all these variety of reasons of why we're failing. And at the heart of it, right, there's a few core things here. First of all, whenever we're doing work, there's always the opportunity cost of all of the other work we could have done instead, especially when it comes to data work. There's so much that you can do with data that to do the wrong thing is, it almost hurts sometimes, right? I think of like what we could have been doing instead. Right? And then the major problem with all of this is the fact that there's this disconnect between us in the data world and the ecosystem in which we're living of where our work integrates. And we're either not understanding where it's integrating strongly enough, or we're handing it off and that handoff is flopping somewhere. Cool. So let's dive into this just a little bit more here. Oops. Let's go all the way back. All right. By the way, I'm going to use Miro here to present. I've never done this before, so thanks for bearing with me on this. You'll probably have seen something like this at some point in your life, right? You're trying to figure out what work to do. You think of all these ideas. Every dot on this graph represents some work that you could be doing, and you put your value on one side, you put how much effort it's going to take to do it on another side, and you start figuring out what you're going to do, right? And ultimately, if you're doing work, you start from this corner, and you work your way all the way up to, actually, don't do that corner. That corner, never do it, right? If you use up this whole corner, think of more ideas. Don't keep going that way, right? But generally, you're working in that corner. And if you plot all this out, optimally, you'll say, whoops, you'll try to say, like, just stay in that corner, right? Do only the work in that corner. So going back to why data teams fail, at the heart of it, right, and you think of all those reasons in that little mind map, at the heart of it, we're essentially doing the wrong work. What do we mean by doing the wrong work? It means that we've taken on one of those guys up over there when we should have been doing one of these down over here. Right? That's essentially what we mean when we say doing the wrong work. We're doing work that didn't have the value we thought. Or worse, we thought one of those folks was all the way over there, that it had a ton of value, but it didn't. Right? Or we thought it was down here and it was really easy effort, but it turns out it's much higher effort. Generally, if we've done the wrong work, it means we've messed up one of these two things, right? We've estimated the effort wrong, or we've estimated the value wrong. Right, so how do we actually go about doing this? All these initiative names, by the way, they're just made up words. You probably put together a spreadsheet like this at some point in your life, or maybe you've seen one of these put together. You go around, you think of all the ideas you want to do, you put together how much value, how much effort. People call it different things, return, investment, complexity, what have you. And ultimately, you calculate some sort of score. I love this in the concept of data science, because what we're actually doing when we're thinking about what work to do, if you look carefully at what we have is, we have an optimization problem. We have these inputs, which are value and effort, and we're going to output something, right? Essentially, it's a ranking problem. We're going to rank all of these. However, this is where I think a lot of us, So essentially, any team, given that you have limited resources, if you have infinite resources, you can get all the work done, right? But if you have a limited amount of time, limited amount of resources, you need to essentially draw a line along your graph that says, I'm going to do the stuff below this, beyond this line, the stuff that has high value relative to the effort I'm going to put in. Anything beyond that is outside of the scope of my resources. If you want to give me more resources, sure, we'll go get more stuff done. We can move that line back. But without the amount of resources we need, that's the only work we're going to do. But there's a big problem. It doesn't look like this. What it really looks like is something like this. Right? Meaning, and each one of these blue clouds is, let's call it an initiative, a piece of work. we don't actually know what the value of the work is, and we have no way of knowing what the effort is. And I say that kind of loosely, but not really at all, right? We can guess what the effort is. And so one thing I would really love to invite everybody here to think of is when we think of the value and the effort of a piece of work, when you're looking at a work and you're thinking it's valuable or how much effort it's going to take, to think of those as random variables. They are, in fact, random variables from a chaotic process. They're stochastic in nature. And what we want to do, and in order for data science to succeed, is to be able to reduce those error bars, right? To estimate them more accurately, to estimate the effort, estimate the value more accurately. Right? And a lot of times, you'll see this, if you read some product management blogs, they're going to tell you something of like using these 3-column way of prioritizing work, right? And they'll tell you, oh, it's the value, it's the effort, but also the confidence, right? How much confidence you have in your estimates, right? But we work in data science, we can get a little smarter than that, and we can recognize that confidence overall in the whole thing doesn't really make sense, because what does that even mean? On value itself, we have confidence, and on effort itself, we have confidence. And each of those are random variables. It's not the entire ecosystem, right? And so I really just stick with these two things. And there's a whole other aspect of how do you even figure out what the value is? How do you figure out what the effort is? But, oops, I lost my presentation. Let's try this again. All right. And so one of the big challenges is if we're unsure about what exactly the value is and what exactly the effort is, well, we don't even know whether or not we should do it and whether or not we should prioritize it. Right? If this big old blob of a thing, normally what happens is we say it's over here, right? Most initiatives that failed, I'll bet you anything, if you look back on it, we're going to say this is where it was at, right? Before we started, we said it's over here, and that's where it ended. If you look back at any initiative that you've undertaken that has sat on a shelf or that just really wasn't a success we hoped it would or took way longer, think about where you would have plotted it beforehand. That's your prior. You did the work. That's your posterior. And then where you plot it. And ultimately, what we want to do is we want to be able to resolve from this big old hazy thing of a cloud down to a more precise estimate. And if we can get that precise estimate, then we can focus on doing the right work. Overall, if you think of the expected value of our entire team, of our entire work, of us over the course of a year, 5 years, whatever you want to put that as, we're maximizing that. And we're doing it, and we can actually do it algorithmically in a really fun way, which is we could take that big old blob of a thing, and instead of going through and undertaking that project, what we decide to do is we take on a small little bit of it, and the purpose of that project is not to complete it. The purpose of that project is to get enough information so as to decide should we continue doing it or not. We're trying to deduce what is the true value of the work, what is the true effort of the work. And so we want to do just enough, sorry, I'm using the word work twice, but we want to do just enough work to understand how much effort, how much value this, I'm going to call it a project, how much work, effort, and value this project actually has. And as we start doing a little bit more and a little bit more and a little bit more, the uncertainty starts to get narrower and narrower and narrower. Right. And so what we're trying to do ultimately is we've got this big old cloud of a mess, and we're trying to figure out, is it going to be above or below that vector? Right? Is it going to be work that we should do or shouldn't do? And we're trying to do a little bit of work to understand that. And if we continue to do this with each piece of our projects, well, we end up, when we look back at all the work we've done, we realize that we've built a team that is highly successful and accomplishing a lot of really great things, building amazing models, that those models get used and those models get integrated into really great work. I have this concept called the 2-day rule. It's a little bit cheeky, but I mean it very sincerely, which is anytime you take on a project for the very first time, an initiative for the very first time that you've never done before, never plan on spending more than 2 days on it. If you think about how many works we plan out, that we plan for a month, right? Someone comes to us, our marketing team comes to us. It's like, hey, could you do this, whatever, some really important piece of work for us? Yeah, of course, it'll take me about 3 weeks, 4 weeks. and then it ends up taking about 2 months. Right? If we think it's going to take 2 days, it's probably going to take a week, maybe 2, right? And we want to keep it as narrow as possible the first time we do it, and the second time as well, until we really understand what is the value and effort of the work. Running out of time, so I'm going to go through this really fast. Handoffs, focus really heavily on handoffs. I'm going to jump through this pretty fast, but handoffs is the other really important part of data work. Our work, it's a very humbling idea to recognize that our work in itself does not have direct value. The value comes from integrating and partnering with someone else, and our work, we need to do something with it. We produce a really awesome model. What are we going to do with it? If we don't know what that is, then we can't actually produce the value of our work. And so we need to really figure that part out. And then lastly, having these talks, in order to really understand what it is that our work is doing and where it's integrating, we need to have some really important conversations with the folks that we're interacting with. Right? And this is really challenging for some folks in data. And what I found is there's people in data who freaking love it, right? And they're really integrate deeply into all the other aspects of the context of the data, let's say. And then there's other folks who are in data because they never want to have those conversations. And to those folks specifically, of which I was one of those for quite a while, I'd say learning to have these conversations, learning to really deduce what is the value of the work can help ensure the success of yourself as a team and of us as a team. So to wrap up, 3 really simple takeaways. First and foremost, recognize the value and effort, that these are random variables, and what we need to do is we need to estimate these. So spend your initial time estimating those before deciding what work to do. Build up to that in iterative fashions. We have a very great algorithmic approach, which is just do a little bit of steps, right? Work broadly, don't go very deep. Avoid greedy algorithms, get as much information as possible, take a few steps in order to understand the value and effort, and then really decide on the 1 or 2 massive projects you're going to take on. And most importantly, we must be responsible for our work getting used. This is a really challenging one, especially, again, for folks in data. So many times I've heard folks say, well, I'm going to make this model, I'm going to do this analysis, I'm going to give it to them. Whether or not they do anything with it, I can't control that. That's up to them. Of which, yes, that's totally true. This is not something you can control once you've already handed it off, once you're done with the work. This is something that gets controlled before you decide to start doing the work. So before you start doing the work, you have to figure out how is it going to be used. And we have to be responsible for that to make sure that our work actually makes it all the way through till someone can use it. And that is about it. I'm a little bit over time, but thank you all very much for your time today. Appreciate it.